We just talked about quartiles, and more specifically the third quartile and the first quartile. So now we're going to talk about box plots and 5-number summaries that will use those concepts. So a 5-number summary gives us some values in our data set, and those values are the minimum. Sometimes you'll see that called the lower extreme, but really it's just the lowest value in our data set. The first quartile, which of course is our 25th percentile, which is also the median of the first half of the data. The median, which is our 50th percentile, it's the middle of our data. The third quartile, which is the 75th percent, so this would be sort of considered the 0. And then the maximum or the upper extreme, which would be whatever our highest value is. So we can see we're just finding all 5 of those values. So before we actually make them ourselves, let's pay attention to what they actually mean. So I'm going to work through this one with you rather than have you try it on your own. So the middle half of a tsunami causing earthquake is between what 2 values? So middle half, right away that tells me that I'm looking at the distance between my first and third quartile. So the middle half would be between the 6.7 on the Richter scale and the 7.6. Oops, didn't want to give you all the answers. The 6.7 and the 7.6. The largest tsunami causing earthquake has a magnitude of what? Well, that would be whatever our max is, which is 9.1. So 9.1 here, this was 6.7 and 7.6. Half of the tsunami causing earthquakes are above what? Well, half above means that I'm looking at the median, the 7.2. So half of them are above the middle value. So middle half is between Q1 and Q3. Largest would be our max. Half above would be above the median, so up here, all of this stuff. And a tsunami causing earthquake that is less than what is small? Well, I would say less than our Q1 data, because the middle half of our data is between Q1 and Q3. That means from here up is 75% of our data. So if it's below that Q1, then it's probably pretty small. So I wouldn't say below the minimum, because the minimum is the minimum. It can't be below that. So these are the values that we would answer. Well, let's actually make a box plot out of those values so that we can kind of understand what a box plot will tell us. So the first thing we have to do is find the 5-number summary. And we're going to plot all of those values above the number line. So we're just going to put dots above the number line that have those values. And we're going to do one of these together. Then we're going to draw a box around those quartiles and the median. And then we're going to do a fence. Now the fence is super duper important because we talked about outliers and how to know if something is an outlier or not. So the outlier rule basically says, let's make this imaginary fence, and anything that's outside of that fence is going to be an outlier. An outlier being an unusual value, something that we're surprised by. So then we're going to draw our whiskers and mark any outliers with a dot, star, etc. The imaginary fence is found by taking 1.5 times the interquartile range, which means we have to find the IQR, which of course would be that Q3 minus Q1, and then we're going to take that value times 1.5. I'm going to then add that value, whatever this is, to the upper fence and subtract it from the lower fence to get a fence outside of the ends of the box. So let's take a look at what this looks like. Here are my data values. Now, unfortunately, these are not in order. So I'm going to go ahead and write them in order first. Super important that you do that, so take the time to do that on your own. Okay, I've written my data in the correct order now. And one thing that I like to do when I get done is to count how many values I have here and count how many values I have here to make sure I didn't miss one, because it's pretty easy to mess up. So I have 13 values in each row, so I know I have them all. So now I'm going to make a box plot using this data. There are 5 pieces of information that I need. One of them, of course, is my lower extreme or minimum. One of them is my upper extreme or my maximum. And then I'm going to use what I know about a median. So we just talked about how to find a median. I'm going to count in. There were 13 values, so I know that half of 13 is 6.5. So it's going to be that 7th value. 1, 2, 3, 4, 5, 6, 7. And again, I could count in from this side to verify. 1, 2, 3, 4, 5, 6, 7. So this is in fact the middle value. This is my median. And then from here, It's a little bit different depending on if your median is an actual value or not. If the median is an actual value, don't include it in your data set. So I'm looking just now at these values and at these values, and I want to find the middle of these values. There's 1, 2, 3, 4, 5, 6. So counting in from the outside, I would land at 28 and 31. And 28 and 31, I would then average to get 29.5, and that would be my Q1. And then I would do the same thing here, 1, 2, 3, 1, 2, 3. I would end up at 48 and 56, which would give me 52 as an average, which is my Q3. So basically, I'm going to put a point on my number line, but above it, at 22, at 29.5, at 35, at 52, and at 67. For the middle 3 dots, which are my quartiles and my median, I'm then going to just make a box. So I'm going to make straight lines through those and make a box, and then I'll connect the whiskers to the outside. Now let's not forget to do our fence. Our fence is to find the IQR, which is the interquartile range, which means I'm going to take 52, which is my 3rd quartile, minus 29.5, and that's going to give me my interquartile range of 22.5. I'm going to take 1.5 times 22.5, and that's going to give me my value that I'm going to add and subtract to make the fence, which is 33.75. So this would be my 1.5 times my IQR. That value needs to be added and subtracted to these values. So my Q1 minus 33.75 gives me negative 4.25. And then Q3 plus that value would be 52 plus the 33.75, which would be 85.75. So those are my fences, which means on my graph, I would just draw a little dotted line at negative 4.25, so we'll say somewhere in here, and at 85.75, which is somewhere in here. Now, if I had a value, a min or a max or any other value that was outside of that line, those would be considered outliers. In this case, I don't. So here are my values, there's my graph, and of course my fence, which I didn't have on there. So I would like for you to go ahead and try this one on your own to make a box plot, one for each, so one for the men and one for the women. So press pause. Go ahead and do those. This should be a little bit easier because it's already in the correct order for you, and then press play to check your work. So for the men, again, I've got a smallest value of 22, a median of 31, and a largest of 38, and then I would look then at 34 being my Q3, and at 25 being my Q1. Same thing over here. I've got median, that's the one in the middle. Half of this data, that would be 41, half of this data would be 61, and then the smallest and the largest. So using those values, I should get these box plots, and again, you could find those fences.